The passage of time is quantified by comparing it to repetitious series of events. Examples of series of events that have been used to quantify time are the yearly motion of the Earth on its orbit, the regular motion of a pendulum, and the duration of the arrival of a certain number of microwave radiation of the cesium atom. I'm only mentioning this last example because it is now related to the most precise way of setting how long 1 second should last. The characteristics of time as a quantity is that first, it is a scalar. It does not have a direction in space. We will reserve the letter small t for the variable naming equations. In order to quantify time, you need to choose an event that happened at time t equal to 0, such as the beginning of a race or your birth. The value for time can be negative. It only means that events occurring at negative values of time occurred before the event chosen to occur at t equal to 0. Finally, the usual measurement units for time are second, minutes, or hours. We have defined two physical quantities so far, position and time. We will now see that these two quantities can be connected through a mathematical function. Let us review what a function is. A function is a unique connection between an element of a starting set, called the domain, and an element of a finishing set, called the range. Unique is a key word here in this definition. If you consider an interval of time as your domain, and the existence of an object during the interval of time, to each value of time during that interval, the object needs to be somewhere. Remember, the object does not explode. And it cannot be at more than one location at each time because each position defines a single point in space. The position is then a function of time. This link could be expressed through a mathematical expression. Let us go back to the example of the straight road between Toronto and Montreal, which are 600 kilometers apart with Kingston midway between them. We will choose the origin at the location of Toronto and the x-reference direction pointing from Toronto towards Montreal. The component of position of a car traveling between Toronto and Montreal could be summarized with this mathematical expression. Just to get a feeling for the trip, you can substitute a few values of time. If you substitute t equals 0, you get an x component equal to 0 kilometers, which is the origin, so in Toronto. At t equals 3 hours, the car is in Kingston. And finally, the car arrives in Montreal at 6 hours, which is 6 hours after leaving Toronto. Notice that if you were dealing with a two-dimensional problem, the x and y components of position would each need to be associated with a function of time. There is another way to provide information about where an object is as a function of time. You can make a graph of the function. The horizontal axis is for the independent variable, which here is the time, and the vertical axis is for the dependent variable, which is the x component of position when it is the only component of position. The previous example of a trip between Toronto and Montreal was represented mathematically by this expression. Notice that this is the equation of a line with a y-intercept of 0 and a slope of 100 kilometers per hour. Its graph would look like this. This way of showing the relation between component of position and time is basically only useful when working with a one-dimensional case. The subscripts I or F can be added to the variable names of quantities that varies with time. They are abbreviations for initial and final, respectively. If Q is such a quantity that varies with time, then Qi refers to the value of the quantity Q at the beginning of the time interval, QF refers to the value of the quantity Q at the end of the time interval. Since time is a quantity that varies with time, the notation can be used to create a variable named Ti for the time at the beginning of the time interval and Tf for the variable name for the time at the end of the time interval. In mathematics, a typical way to describe an interval is square bracket Ti, comma Tf, square bracket, which refers to the set of time values between Ti and Tf and including Ti and Tf. For example, square bracket minus 3 seconds, comma 6 seconds, square bracket, refers to all the values of time between minus 3 seconds and 6 seconds, including the endpoints. A calculation that is often done is evaluating the change of a quantity over a time interval. If the symbol delta, which looks like a triangle, is placed before a variable, it is the change of that variable over a specific time interval that is required. Delta means change of. Delta Q can be evaluated by subtracting Qi from Qf. If the quantity Q is time itself, then its change of time is Tf minus Ti. For example, for the interval from minus 3 seconds to 6 seconds, the change of time is the final time, 6 seconds, minus the initial time, minus 3 seconds, so the answer is 9 seconds. The next step is to work with the change of the other quantity we have defined so far, which is position. The change of position will be the subject of the next installment.